Irrigation was essential to provide the agricultural productivity that allowed the Hohokam to flourish and thrive in the desert. In this artist's reconstruction, we can see how irrigation was a communal activity and required the coordinated efforts of a large number of people within the community to control the flow of water, to distribute the water to different fields, to harvest the crops. This is an effort that brought the community together, brought villages along canals together into larger communities. And irrigation allowed tremendous productivity that underwrote the exchange systems we have already talked about. This map shows the prehistoric canal systems found in the Salt Gila Basin. You can see along the Salt in the north there are large canal systems on both the north and south sides of the river, and along the Gila to the south you can see somewhat smaller canal systems. The Gila and the Salt have different flow characteristics because they have different sources of their water. The Gila River has less water in it than the Salt does during some seasons of the year because the Salt has a much larger drainage. The Salt drains the entire Mogollon Rim in the Verde Valley, whereas the Gila River has a much smaller drainage, draining from mountains to the east. The Salt is a larger, much more powerful river that may have presented more challenges to managing irrigation along it than the Gila, which had a lower volume and flow, and potentially less destructive floods that may have occurred. You can also see that there are some small canal systems along Queen Creek between the Salt and the Gila. These canals were very large. Here we see a photo taken in the early 1900s of the entrance to the Scottsdale Canal system at the Salt River. You can see in the background on the right-hand side the Salt River and the man standing in the base of the canal. The canal is excavated and the excavated soil piled up on either side of the ditch, creating adjacent berms. The berms help elevate the water that is within the canal above the elevation of the surrounding land, because you want the water to be above the land that you're going to irrigate, because water only flows downhill. If you drive south from Maricopa Community College along Dobson Road, as you get between Guadalupe and Elliott, you cross over the Western Canal. And if you look along the canal, you will notice that the water within the canal is elevated above the surrounding land by the berms that define either side of the canal. While dug by hand, these prehistoric canals were as large and impressive as many of the modern canals that are found in the Phoenix area. They can be as up to 50 feet wide and 15 feet deep, where they are taking off of the river in order to deliver the water out into agricultural fields. Here is another view along a segment of the Scottsdale Canal system. As you can see, it's large enough to drive a truck along the bottom, as the tire tracks in the bottom of the canal demonstrate. This segment of the canal is now under State Route 87. When the highway was widened several years ago, archaeology was done in advance of that, and this canal and other features associated with it, smaller lateral canals that delivered water to fields, associated settlements, and other portions of villages were excavated prior to the construction and the destruction of these cultural resources. The development of modern Phoenix, especially the construction of the freeways, has provided a lot of archaeological data that has been used to reconstruct prehistoric canal systems, to understand how they were built and used. The first observations of the prehistoric canal systems were made in the 1860s by some of the first American settlers in the region. It's a common myth that the early settlers just dug out prehistoric canals and reused them. They couldn't because the gradient of the Salt River had changed since these prehistoric canals had been built, and the level of the salt was too low to allow flow into these canals. However, these canals did provide early settlers with an understanding of the lay of the land and the gradient upon which the new canals that they would build must flow. In fact, many of the modern canals parallel these earlier prehistoric canals. The map we see here was made in 1929 by Omar Turney, who was the city engineer for Phoenix. It was his job to maintain the physical infrastructure of the growing city of Phoenix, the canals, the roads, and as he was out doing his work, he documented the prehistoric canals and the villages associated with them. So this is the first comprehensive map showing all the information that was known at the time of these prehistoric canals and the distribution of villages along them. Additional research since Turney's day has revealed even more detailed information about these canals. And in the 1990s, Jerry Howard and Gary Huckleberry were contracted by the Arizona Department of Transportation to compile all of the information known about canals and create this map. This map is very important for planning purposes when ADOT or other federal, state, or local agencies are planning for different developments. They know the location of canals and associated villages and know areas that need to have archaeological research done prior to any ground disturbing activities. These canal systems were extensive and irrigated tens of thousands of acres, allowing agricultural production here in the dry desert. This artist's reconstruction shows some of the diverse activities that were practiced in the agricultural fields, because it's not just canals and fields. As we can see in the center left, there are also reservoirs or ponds that were created along the canal to store water for residential use. In the irrigated fields, people are cultivating a variety of domesticated crops, squash and beans and corn. But we also see the encouragement and in some cases the actual planting of certain wild plants. Saguaros would not be removed, they would be allowed to remain. But we see in the very center there below that saguaro a row of prickly pears, and we know that historically autumn farmers would plant prickly pears and cholla along the borders between fields, almost like the earliest barbed wire fences separating fields. But these aren't just field dividers, they also provide resources. They provide the young pads that can be eaten, or as seen here, the fruits that are being harvested. This is a large-scale managed landscape, not just for the cultivated plants, but for associated wild plants or encouraged wild plants. The canals also provided opportunities for fishing, as fish would swim into the canals, and in some cases a certain type of fish, the Colorado River pike minnow, a very large fish that could grow up to 3 to 4 feet long, would often move into the canals during its breeding season and be very easily captured. Much of the modern urban Phoenix area overlies these prehistoric canal systems and villages. This is a map that shows Canal System 2 on the north side of the Salt River. It begins just east of the airport, where Pueblo Grande is, and then flows through the area that is now downtown and west of downtown. So on this map we can see not only the prehistoric canals in blue, the prehistoric villages in the orangish-brown color, but also modern streets that can allow you to see the relationship between this prehistoric canal system and the modern city of Phoenix. Canal Grande on the north is the longest canal that the prehistoric Hohokam built and is 16 miles long, stretching from Pueblo Grande all the way out into Glendale near the Cardinal Stadium. While we have some information about the earlier Pioneer period canals, we don't have a full understanding of the entire extent of these irrigation systems during that time period because of later reconstruction of colonial sedentary and classic period canals have obscured the earliest canal systems in the Phoenix area. But we have a relatively good understanding of the full extent of these later periods. This map shows Canal System 2 during the colonial period, and it was already quite large, irrigating tens of thousands of acres and supporting a very large population. These were earthen canals. Unlike the modern canals we have in Phoenix, they did not have concrete lining. And as water flows through an earthen canal, it is eroding soils from some places and depositing them downstream. And these canals require constant maintenance and periodic reconstruction because of the effects of erosion and deposition. During the sedentary period, the canal system was re-engineered to make it more efficient, to run at a lower gradient and distribute water further away from the Salt River and allow irrigation of more land. Canal System 2 reached its greatest extent during the Classic period, when Canal Grande was extended to 16 miles from the Salt River out into modern Glendale, and many parallel canals were built in order to more efficiently use water along the northern reaches of the irrigation system. Excavations conducted related to various development activities in the Phoenix Basin from the 1970s to the present have provided a tremendous database on the canal systems, allowing us to understand how they were constructed, how they were used, how they were managed, and particularly how well engineered they were. Here we see the former city archaeologist for Phoenix, Todd Bostwick, standing in a backhoe trench that has cut through a canal, revealing in cross-section the canal and its sediments. The trench is stepped, so there is a horizontal surface where he is laying his arm on. You can see below him the lowest levels of the canal, and then in the wall to his left, the upper half of the photo, continued sediments as we go up in the canal. The various sorts of divots that have been excavated into the wall is where soil samples were collected to look at changes in the soils within the canal that allow us to understand how the canals were used. Characteristics of the soils themselves can tell us about the water that was flowing through, how much water, was it standing water, was the canal seasonally dry. Pollen also provides information on the types of plants that grew adjacent to the canals, as well as wetland plants that grew within them, and may provide information as to whether canals had water in them year-round. Another line of evidence that allows us to reconstruct the nature of water use is small creatures called ostracods. These are small mollusk-like creatures that are related to barnacles that free swim in waters and leave behind tiny microscopic shells. Different ostracod species have different water requirements. Some require water that is very clean and oxygen rich. Others are more tolerant of saltier, dirtier water. Some require water year-round. Others can live when there is only a seasonal availability of water. So the different species of ostracods that are present allow us to understand the nature of water use along the canals. In general, it seems most of the primary canals had water within them year-round. Canals are not just used to deliver water from the river out to the fields. Canals are like long linear reservoirs where water can be stored and distributed later. Evidence suggests that the smaller delivery canals, those that delivered water from the primary canal into the fields, often did not hold water year-round, but would have water put into them to deliver to the fields and then would dry out. Much of our understanding of Hohokam canals comes from the work of Jerry Howard, who is an adjunct faculty here at MCC and is the curator at the Arizona Museum of Natural History in Mesa and the city archaeologist for Mesa. Jerry wrote his dissertation at ASU on canal systems in the Phoenix Basin. And before Jerry began to investigate canals, it had often been assumed that they were built through accretional construction, that people would add to an existing canal system, extending it another half-mile or mile over time, and the canal systems grew in this way. It was suggested that they would require a less labor input if you increased the canal's length over time and expanded the canal system step by step rather than in one single construction episode. Jerry, however, found that that could not have been the case because the canals are very well engineered along their entire length. Canals get smaller as they go further away from the river. At the river, they are very big, they are wide, and they are deep. But as the canal flows away from the river, it progressively tapers to be narrower and shallower. Because as users are taking water out of the canal, there is less water within as you go further downstream. And you need to reduce the cross-section of the canal in order to maintain the same flow of the water along it. The data from all of the excavations done related to the construction of the highways in the Phoenix area and other developments provides a great database of measurements along canals at different locations, so we can see how the width and depth changed along the length of the canal. And Jerry found that it changed according to a standard mathematical formula, one that is almost identical to formulas you would find in modern books for canal engineers. That the prehistoric Hohokam worked out these same systems of how much water flows at what rate, and therefore how much we need to reduce the width and depth of the canal to maintain that same flow of water as users remove water from the canal along its length. This engineering would have required the entire length of the canal to be built in one episode, rather than just adding on accretionally year after year. And evidence suggests that the canals were built in large-scale episodes and were rebuilt periodically, not just maintained, but periodically had to be completely rebuilt because of the buildup of sediments along the lower ends of the canals and increased erosion along the upper reaches where they first come out of the river. Dr. Howard's research is ongoing, and we are developing a greater understanding of the operation and construction of these canal systems. And without Jerry's insights, we would not understand the incredible complexity and the engineering genius of our prehistoric ancestors here in the Phoenix area. Irrigation was essential for the production of cotton. Cotton is a very water-thirsty plant, and it cannot be grown without irrigation. Cotton was really important for the Hohokam. The Hohokam were the primary producers of cotton in the southwestern United States, and prior to 1100 they were the only producers of cotton. After 1100, new varieties of cotton were developed that could be grown at higher altitudes and were grown along the Little Colorado River and near the Hopi Pueblos, and also along the upper Rio Grande River in New Mexico. But prior to that, the only source of cotton was the Hohokam, and it was grown not just for the consumption of the Hohokam, but as a commodity that was traded to other people. In addition to being a very water-intensive crop, cotton has the ability to grow in very salty soils, and the Salt River is called the Salt for a good reason. It does carry a lot of dissolved solids, particularly salts, which irrigation waters deposit in the fields. But cotton is highly tolerant to salty soils, and therefore it was an ideal crop to grow in this area. Cotton may have been one of the most important resources that was exchanged between Hohokam communities and with their neighbors. And so cotton production was very important to understanding the nature of Hohokam economies. The production of cotton allowed people to trade for wild resources from adjacent areas, for stones that were required to make stone tools that were also found in areas outside of the Salt Gila core, and it was a desired commodity that couldn't be produced outside the Salt Gila core. So it was a very important resource, and it really fueled the growth of Hohokam exchange systems.